Hello everyone. I hope you are okay. We are continuing with finding the general solution. Mm, Please, guys, if you are new to the channel, don't forget to subscribe. Uh, and to those who are regulars here, thank you for coming back and trusting us with with what we teach you. I really hope the videos we keep uploading. There's a thing or two that you are learning, or misconception that you are misconceptions rather that you are rectifying. uh, we're just going to solve here, find a general solution. I will do a couple of examples or equations rather together. Okay, the first one we have, let's start with the basic one. Let's say we have cos squared theta plus sine theta plus 1 is equal to 0. Together, the steps of finding the general solution, they go like: check whether there are two things you can change into one thing, and then you must change everything into one trig ratio. If you can't, just change everything into sine and cos. Together, 99% of the times whenever you're dealing with general solution, you'll be just focused on changing everything into one trig ratio, or just changing everything into sine and cos and then finding a general solution. Together. Okay, if you're struggling with how to find general solution, please go to lesson number 33. Yes, where I teach about general solution, the lesson before this one. Okay, here the first step is to change everything into one trig ratio, because we have sine, which you cannot do anything about, but we can change cos squared theta in terms of sine. So we can write this as 1 minus sine squared theta. Then we continue with plus sine theta plus 1. This is equal to 0. Are you together? And then now we must write this equation into standard form. Yo, who the hell is this? Excuse me about that, guys. And excuse me with my French as well. So I'll have negative sine squared theta plus sine theta plus 1 will give us 2, right? And then before you solve here for theta, guys, you must make sure that the variable with the highest exponent is positive, so we can divide each and every term we have here by a negative 1, and then we'll find and then we'll find sine squared theta minus sine theta minus 2 is equal to 0. This thing is factorizable, guys. Don't be confused by the trig ratios. You can either look it like we have y squared minus y minus 2. We are supposed to factorize when the factors of 2 that when you subtract will give you 1. Now together, just look at it like that. It wouldn't confuse you, because trigonometry and algebra are just one and the same thing. So we have sine theta, the factors of 2 that when you subtract will give us 1. It's just 2 and 1. The bigger factor would always take the sign of the middle term. It's minus and plus here, so sine of angle theta is equal to 1, or the sine of angle theta is equal to 2. This one, there wouldn't be any solution for this one. Why? Because this term is not between a negative 1 and 1. But for this one, we can find a solution. Right, together, the first thing we need to do is to find our reference angle. Our reference angle is the inverse of sine 1 and then we'll get 90 degrees. Our duty is to express the 90 degrees where sine is negative. Sine is negative in the third and the fourth quadrant. So I'll simply say, therefore, in the third quadrant, I'll express theta as 180 plus my reference angle, which is 90, plus k 360, where k is an integer. And then in the fourth quadrant, how I would express my answer, I would say theta would be 360 minus my reference angle, which is 90 degrees, plus k 360, where k is an integer. Okay, so therefore my final answer for the first one will be 180 plus 90. It will give me 270 degrees, plus k 360 excuse me, where k is an integer. And then for the other one, 360 minus 90 will also give me 270, plus k 360, where k is an integer. So this is the general solution, guys. Are you together? That's the basic part of finding the general solution. Change into one trig ratio. If you can't, just change everything into sine and cos. Are you together, guys? Let's do the second one. We'll go with, now we have double angles, sine 2 theta plus cos 2 theta minus 1 is equal to 0. Remember, there's lesson 31, 30 or 31 between the two, whereby I was explaining the double angles on where and how to use it, especially the one of cos. So this thing, for sine has only one double angle, so I'll simply change this to 2 sine theta cos theta plus, and then for cos, since I have a negative 1 next to cos, that means I must put, or I must substitute the double angle that has a positive 1, because the aim is to eliminate the one which is added or subtracted. Are you together? So I'll have 1 minus 2 sine squared theta, and then I still have a minus 1 there, like this. Are you together? And then I will be left with 2 sine theta cos theta. The ones will subtract. I'll be left with negative 2 sine squared theta is equal to 0. What I can do here is to take out a common factor. A common factor can be negative 2 sine theta. Or before I do that, let me just make the variable with the highest power to be positive. If I can divide every term by a negative 2, I will be left with positive sine squared theta minus sine theta multiplied by cos theta. Anything divided, 0 divided by anything is 0. Are you together? And then therefore I can take out a common factor on the left hand side. I have sine theta, and I have sine theta minus cos theta now is equal to 0, right? So I have sine theta is equal to 0, or sine theta minus cos theta is equal to 0. Are we together? For the first one, let me write in blue. I'll first find my reference angle, right? I'll simply say sine inverse of 0. I know I'll get 0, right? Then I must express 0 as sine is positive. So what will I do? I'll simply say theta is equal to 0 plus k 360, where k is an integer. or theta is equal to 180 minus 0, which is 180, plus k 360, where k is an integer. Alright, together. And then now let's deal with this one. Okay, I can say that sine theta is equal to the cos of theta. Alright, together. In this case, guys, I can divide by a trig ratio. Why am I doing that? Because whenever I divide, it's not like that trig ratio will be eliminated in my equation. Alright, together. So whenever I divide both sides by cos theta, let me do that in red. Cos theta over cos theta. Alright, together. We can also see that this side the cos will cancel, but I will still have cos theta in the equation. Alright, together, because on the left hand side it doesn't cancel. So I'll have sine theta over cos theta, which will give me tan theta. Cos theta divided by cos theta will be equal to 1. Alright, together, and therefore my reference angle will be tan inverse of 1, and that will give me 45 degrees. My duty is to express 45 degrees where tan is positive, but remember that for tan we only express angles in the first and second quadrant. If tan is equal to a positive number, your angle should be expressed in the first quadrant. If tan is equal to a negative number, angles should be expressed in the second quadrant. Are you together? So in this case, I'll simply say theta is equal to, in the first quadrant, I'll just write angles as they are, plus k 180, where k is an integer. Please remember that the period for tan is always 180. Okay, let's do another one. Another one. Another one. Let's say we had one over cos squared theta minus sine squared theta is equal to 1 minus sine theta plus tan squared theta, right? Okay, whenever we deal with general solution, guys, I did say that you have to change everything into sine and cos before you start simplifying. I have 1 over cos squared of theta minus sine squared of theta is equal to 1 minus sine theta plus, this is sine squared theta over cos squared theta. Okay, we can all see that we have an LCD here, which is cos squared theta. If we are solving an equation and we have fractions, I don't want to solve equations with fractions. That means I must multiply each and every term with the LCD. If I multiply 1 over cos squared with cos squared, I'll simply get 1, because the cos squared will cancel one another rather. And then here I'll simply get sine squared theta multiplied by cos squared theta, and then here I will get cos squared theta minus sine theta times cos squared theta plus sine squared theta. Are we together? Okay, and then here I think I must just bring everything into one side and 0 on the other side. So I'll have 1 minus, please note that the ones that I take from the right hand side, I'll just write them in black. 1 minus cos squared theta minus sine squared theta and then I will have a negative sine squared theta cos squared theta plus sine theta cos squared theta is equal to 0. Are you together? Everything that I took from the right hand side, I've written it in black. And then everything which is in red is these are just things that were already on the left hand side. Okay, I can change this part here into one thing. I can write this as sine squared theta. Okay, remember that I still have a negative sine squared theta and a negative sine squared theta cos squared theta plus sine theta cos squared theta is 0. Are we together? The first two things will subtract one another. Sine squared minus sine squared will give us 0, and then we will have a negative sine squared theta multiplied by cos squared theta plus sine theta multiplied by cos theta by cos squared theta. Ne? Okay, I can divide everything by a negative so that I can have a positive sine squared theta multiplied by cos squared theta minus sine theta and cos squared theta. I can take out a common factor here, guys. Ne? My common factor will be sine theta multiplied by cos squared theta. Are you together? Whenever I do that, on the first term I will be left with just sine theta, because whenever it says sine squared theta, it means I have two sine thetas multiplying one another. Whenever I take one of them outside, I'll be left with one. Are you together? And then on the second term, whenever I take out my common factor, I'll be just left with a negative 1. Are you together? So here I will simply have three things multiplied and the answer is 0. It means that sine theta can be equal to 0. Cos squared theta also can be equal to 0, or sine theta minus 1 can be equal to 0. Then all I need to do is to just find the general solution. The general solution. For the first one, let me give them some space so that I can write them properly. Sine squared theta, or okay. The first thing we need to do, guys, whenever we find a general solution, is to find your reference angle. Sine inverse of 0 will give me 0. Simply write 0 where sine is positive, because 0 is a positive number, right? So I'll simply say theta is equal to 0 degrees plus k 360, where k is an integer, or theta is equal to 360. In the second quadrant, the right angle is 180 minus the reference angle. Ne? This time around, the reference angle is just 0, so I don't have to just subtract 0. So that's the answer. Okay, and then now I have cos squared is equal to 0. Simply means that cos theta is equal to 0 if I take the square roots both sides. And then all I need to do is to find the reference angle. The cos inverse of 0, I'll get 90 degrees. I'll just express 90 degrees where cos is positive. cos is positive on the first and fourth quadrant, ne? So in the first quadrant, you write angles as they are. The reference angle plus k 360, where k is an integer. Are you together? Or say theta in the fourth quadrant, write it as 360 minus theta plus k 360, where k is an integer. So therefore the final answer is just theta is equal to 270 plus k 360, where k is an integer. Are you together? Okay, and then the final one, let me write it in red. I have sine theta is equal to 1. My reference angle is just sine inverse of 1, which will give me 90 degrees. So I'll just substitute, I'll just represent the reference angle where sine is positive. So I'll simply say theta in the first quadrant, just write angles as they are. K is an integer. Or in the second quadrant, theta will be 180 degrees minus 90 plus k 360, right? So therefore I will have theta is equal to 90 degrees plus k 360, where k is an integer. Right, together. So these are my answers: 1, 2, 3, and 4. I don't have to write. I don't have to count these ones as well, because they are the same. This and this are the same as this one, so I don't have to count them. That means I have 4 solutions for this one. Are you together? First thing I had to do was to change everything to sine and cos. After doing that, I multiplied every term by the LCD. Remember that my LCD was equal to cos squared theta. You see, guys, it's important to write down your LCD, because now you know that since this is a LCD, the denominator, since you're dealing with fractions, cannot be 0. So here I should have said this thing is not applicable. Why? Because remember that I had cos theta at the denominator. That means I must not have my denominator to be 0. Are you together? So cos squared theta was not supposed to be 0. So here there is no solution, guys. Thank God I went back. Benizongithukani kodwa kuma comments bantwana bami. Iyo thisha kazi nemaths. Akazi nama restriction. Ngoba nisile nina. Ngiyadlala, guys. Here this one will be not applicable. Why? Because cos squared theta was our denominator. Remember that, and denominators in maths cannot be equal to 0. So the solutions are 0, 180, and 90. These are the only solutions we have. It's important, guys, to write restrictions. Okay, let's do another one. Let's do another one. I'm looking here. Okay, let's try this one. You have 7. Guys, you can pause the video and do this thing on your own first, and then after you've done it, you can come and then you'll do it with me. Is equal to 3. Okay, we have sine 7 squared, so 7 squared sine theta plus 4 sine theta cos theta is equal to 3. Are we together? We are asked to find the general solution. Find the general solution. Okay. We can all see that already we have two trig ratios that we cannot change, and here we have a trig ratio of sine, but there's something that we can do that can help us to be able to solve here. We have sine squared theta plus 4 sine theta cos theta is equal to 3. If you multiply a number by 1, are you changing anything? I'm expecting you to say no. If you multiply a number by 1, there's nothing you're changing, né? Okay, so this is 7 sine squared theta plus 4 sine theta cos theta is equal to 3. How do you express 1 in trigonometry? We express it as sine squared theta plus cos squared theta. So basically on the right hand side we have 3 sine squared theta. We have 3 let me write in red. We have 3 sine squared theta and 3 cos squared theta on the left hand side. Are you together? Now let's bring everything to standard form. Ne? We have 7 sine squared theta. The ones that I'll write in blue, they come from the right hand side. Ne? This is 3 sine squared theta, right? And then I will have 4 sine theta cos theta minus 3 cos squared theta. This is equal to 0. Now everything is in standard form. I've everything on the left hand side and 0 on the right hand side. Ne? 7 squared minus 3 squared will give me 4 sine squared theta plus 4 sine theta cos theta minus 3 cos squared theta is equal to 0. Are you together? This thing is factorizable. Yeah, guys. Just take it as if you are dealing with 4x squared minus 4xy minus y squared minus 3y squared is equal to 0. To factorize this thing is just simple. Just say 4x, not 4x rather. Just say 2x, we have y here, and 3y, I have a minus and plus. The same logic applies there whenever you factorize. Same logic applies. Open 2 brackets. We have 2 sine theta, 3 cos theta, I have a plus here and a minus there. All together, this thing is equal to 0. Okay, so therefore this thing simply means that I have, you don't have a calculator with me, okay, but I'll make a plan. 2 sine theta minus cos theta is equal to 0, or let me write this one in green. 2 sine theta plus 3 cos theta is equal to 0, right? This thing simply means that I can write this thing as 2 2 sine theta is equal to cos theta. And I can divide both sides by a cos here, ne? And then I will have, okay, let me do it. If I divide both sides by cos, I'll simply have 2 tan theta is 1. Are you together? And then this thing simply means tan theta is equal to 1 over 2. Therefore, I must find a reference angle. My reference angle is tan inverse 1 over 2. Let me go look for my calculator. I'll be back. Just 2 seconds. Okay, I have inverse of tan 1 over 2. What should I get? 26.57. Okay, this will give me 26.57 degrees, right? So I must just express my reference angle where tan is positive, ne? I know tan is positive in the first quadrant, so I'll simply say theta will be just 26.57 degrees plus k 180, where k is an integer. Are we together? And then on the other hand, I have 2 sine theta is equal to a negative 3 cos theta. Remember that I can simply divide this thing by cos theta. That means I'll have what? I'll have 2 tan theta is equal to a negative 3. So tan theta is equal to negative 3 over 2. I must just find my reference angle, which is tan inverse 3 over 2. Notice that I don't substitute the negative there. This will give me 56.31. 56.31 degrees. Therefore, my duty is to express theta, or my reference angle, where tan is negative. Tan is negative in the second quadrant. I'll simply say 180 minus my reference angle. My reference angle, remember, that is 56.31 degrees plus k plus k 180, where k is an integer. So this thing simply means that theta is equal to 180 this thing is equal to 123.69 degrees plus k 180. That's how you find general solution, guys. Let's do 2 more before we bounce. Because this thing, guys, is so repetitive. It's so repetitive and it's boring sometimes. Okay, let's do. Pause the video and do it on your own. Pause the video. Find the general solution. Find the general solution. Okay. In this case, guys, I can expand the double angles, or I can just simply use cofunctions. Yeah, let me just use cofunctions because I didn't teach them before. For cofunctions, I can simply write sine 2 theta. Cos 3 theta, I know it can be expressed as sine of 90 degrees minus 3 theta. Whenever you reduce this, it will take you back there. So there's nothing that I changed there. I just changed how it can be expressed at some point. Are you together? When we are here, remember that in algebra, if you had something like this, 2 to the power x is equal to 8, you had to make your bases to be the same, and then you drop the bases because they are the same, then the exponents were going to be equal. In this case, we made the trig ratios to be the same. After the trig ratios are the same, we are just dropping them, and then the angles, we should deal with the angles. But please note that, guys, since the trig ratio that you are left with before you drop it is sine, this thing simply means that we must always express our angles where sine is positive. Are you together? And sine is positive in the first and second quadrant. So in the first quadrant, we'll simply write this the solution for this thing as 2 theta is equal to 90 degrees minus 3 theta plus k 360, where k is an integer. Are you together? And therefore you just solve for theta. If you take the 3 to the other side, you'll have 3 theta, positive 3 theta plus 2 theta, which will give us 5 theta is equal to 90 degrees plus k 360. Are you together? So I can divide everything by 5. 90 divided by 5 will give me 18. So theta will be 18 degrees plus 360 divided by 5 will give me 72, where k is an element of integers. Are you together? If we express the angle in the first quadrant, this is how our answer is going to be. But we must also express it in the second quadrant as well. Let me write it in red. In the second quadrant, we'll say that 2 theta will be equal to 180 minus 90 degrees minus 3 theta plus k 360, where k is an integer. Are you together? And then now all I need to do is to just remove the brackets. 2 theta is equal to 180 minus 90 plus 3 theta and k 360 there. So 2 theta is equal to 180 minus 90 will give me 90 degrees plus 3 theta and k 360. Okay, if I take the 3 theta to the other side, I'll have 2 theta minus 3 theta, which will give me a negative theta. And then I'll have a 90 here plus k 360. I'm solving for theta, not negative theta. That means I must divide everything by a negative. So therefore theta will be equal to a negative 90 degrees. Please note, guys, that for a period I don't need to change the sign. It's not necessary for me to change the sign. Are you together? For the period, it's not necessary for me to change the sign. I can just leave it like this. So this is my general solution. My answers are this and that. Does it make sense, guys? And please note, guys, that we resort to cofunctions if and only if the coefficients here are the same. Are you together? If we had a 3 and a 2 and on the other side, we wouldn't do the cofunctions thingy. That means we're supposed to expand this thing and this thing as well. Does it make sense, sense, bantwana benkosi. Okay, let's do another one. Another one that will need you to do co-functions, ne? Let's just take this one. Pause the video now again. Ish. Just take sine sine 2 theta minus 30 degrees is equal to the cos of theta minus 10 degrees. The same thing, because you can change into sine or change into cos, ne? Since initially you've changed into sine, asiyenze cos manje. Let's do it with cos now. We can write this thing which is on the left hand side as the cos of 90 degrees minus 2 theta minus 30. This thing will be equal to the cos of 10 theta minus 10. Are you together? So on the left hand side I'll have 90 minus 2 theta plus 30 is equal to the cos of theta minus 10. So I'll simply have cos of 90 plus 30 will give me 120 minus 2 theta is equal to the cos of theta minus 10 degrees. Okay, the trig ratios are the same, therefore I must just deal with angles, but I will only express my solution where cos is positive because I'm dealing with cos here. Does it make sense? So I know that cos is positive in the first and fourth quadrant. Are you together? So we will simply write this thing as in the first quadrant, just say 120 minus 2 theta is equal to theta minus 10 degrees plus k 360, where k is an integer. Are you together? So all you need to do is to just isolate theta. When I take the positive theta to the other side, it will be a negative, ne? Then I will have negative 3 theta ngapha. Then the 120, when it goes to the other side, it will be negative as well. I'll have a negative 130. I will have a negative 130 degrees. Okay, this is plus k 360, where k is an integer. Now I'll just divide everything by 3, ne? So 130 divided by 3, a negative 3 rather, will give me a positive 43,33 degrees. I don't need to change the sign for my period. I'll just divide the 360. I'll have 120 plus where k is an element of integers, right? And then in the fourth quadrant, I'll simply write 120 minus 2 theta is equal to 360 minus theta minus 10 degrees plus k 360, where k is an integer. Why am I saying 360 minus? Because that's how angles are expressed in the fourth quadrant. So I'll have 120 minus 2 theta is equal to 360 degrees minus theta plus 10 um, this is K 360. When I take the negative theta to the other side, it will be positive. So I'll have minus 2 theta plus 1 plus theta rather. It will give me a negative theta. Are you together? This and this will give me 370. And then when I say 370 minus the 120 that comes from the left hand side, I'll be left with 250 plus K 360. Are you together? So I can divide everything by a negative 1. So theta will be just a negative 250. Don't need to change the sign of the period. Are you together? So these are my solutions. This one and this one. This is how you deal with numerical functions, guys. You can either work with the cos or sine whenever you deal with co-functions. Let's do the last one. Let's do the last one. Let's fall in love again. I have sine 2 theta is equal to the cos of theta plus 5 all over 3 tan theta. You can all see that, guys. We have a restriction. We have a denominator there, So whenever we solve, must make sure that tan theta cannot be 0. Are you together? And if tan theta cannot be 0, it simply means that even sine theta should not be 0. Are you together, guys? Because if sine theta is 0, then tan theta will be 0, and then our denominator will be undefined. Okay, let's work. We have fractions, when we have fractions, we must always multiply everything by the LCD. Here we just have one LCD, so multiply both sides by 3 tan theta, or you can say that you can just cross multiply. Okay, so we will have 3 tan of angle theta multiplied by sine 2 theta is equal to cos theta plus 5. Now there are no fractions, but what I can do is to change everything into sine and cos. I have 3 tan can be written as sine theta over cos theta. This thing is multiplied by, let me write this one in red. This is the double angle for sine, 2 sine theta cos theta is equal to the cos of theta plus 5. Okay, please note that, guys, since this is multiplying that, so it's safe for me to say this will cancel with this one, right? And then I will be left with 3 sine theta multiplied by 2 sine theta, which will give me 6 sine squared theta is equal to the cos of theta plus 5. Does it make sense, guys? Then now all I need to do is to change everything to have one trig ratio. I can change sine squared to look like a cos, not to look like. I can change it to be in terms of cos. So this will be 6 sine squared can be written as 1 minus cos squared theta. Then whenever I remove the bracket, I'll have 6 minus 6 cos squared theta is equal to cos theta plus 5. Okay, now I'm taking everything to the right hand side. The ones that I'll take to the right hand side, I'll write them in red, and they will change their signs. So I'll have a positive 6 cos squared theta plus cos theta Are you together? Cos theta plus 5, and then I'll have a negative 6. The ones that are written in red, they come from the left hand side. Are you together? Okay, and then this thing simply means that I have 6 cos squared theta plus cos squared theta minus 1 is equal to 0. Are you together? So this thing is factorizable, ne? I'll have 3 cos theta and 2 cos theta, 1 and 1. I'll have a plus and minus there, ne? So the cos of angle theta is equal to 1 over 3, or the cos of angle theta is equal to a negative half. Then how will I write my solutions? Let me deal with 1 over 3 first. Ne? I'll need to find my reference angle first. My reference angle should be the cos of inverse 1 over 3. What do I get? Cos inverse 1 over 3. I get 70.53. This will be 70 degrees. 70.53 degrees, right? Then all I need to do is to express this 70.53 where cos is positive, because cos is equal to a positive number. So this thing simply means that I know that cos is positive in the first and fourth quadrant, right? So this thing simply means that I will say theta is equal to 70.53 degrees plus k 360, where k is an integer, because in the first quadrant we write angles as they are, right? So in the fourth quadrant rather, I'll say theta will be 360 minus 70.53 degrees plus k 360, where k is an integer. So therefore the answer will be 360. The answer will be 289.47 degrees plus K360. Are you together, guys? And then for this one, I'll simply say I must find my reference angle as well. I must find my reference angle. So my reference angle should be the cos inverse of 1 over 2, which will give me 60 degrees. My duty is to express the 60 degrees where cos is negative. I know that cos is negative in the second and third quadrant. So this thing simply means that I'll say theta in the second quadrant, theta is equal to 180 minus 60 degrees plus k 360, where k is an integer. Are you together? So therefore my general solution is theta is equal to 120 plus k 360, where k is an integer, in the second quadrant, right? Then in the third quadrant, I'll write it as 180 degrees plus 60, and then we still add our k360, where k is an integer. So this thing will give me 240 plus k 360, where k is an integer. So these are my solutions for that question. Are you together, guys? Remember that the question was this one. No? Supposed to solve for theta. The first thing I did was to multiply both sides by the LCD, and then I changed everything into sine and cos, and then I changed everything into 1:3 ratio. put everything into standard form, factorized, and then found my general solution. This is how you find general solution, guys. It's this vague. I hope it wouldn't give you problems anymore. Thank you for your time and for your patience. Ngiyanithanda nonke. Bye.